In this video for Computer Science 9618, we're going to take a look at a full Paper 1 walkthrough. So this is actually Paper 1 Variant 1 from 2022. Now, the reason I chose this paper is because it has a lot of various content that is pretty popular on the Paper 1 exam, which is why I chose it. So let's go ahead and let's dive in and walk through this full Paper 1 exam. So computer stored data in binary form. So just this first section, the first page, we have 4 points that we can earn on this Paper 1 exam. Binary, denary, hexadecimal, it will come up. You're going to have at least one 2's complement problem, which we can see in B. So you want to know how to work this out. So what's the difference between a tebibyte and a terabyte? And this shows up in data representation in one of the very first sections in AS. Well, a tebibyte, the key word there, the key prefix tebi, contains 1024 gigabytes. You're not going to go from gigabytes to tebibytes. Now you can, but it's not going to be a nice whole round number. In this curriculum, if they're going to use the prefix tebi or gibby, you're going to use that same prefix, and that is 1024. We know one tebibyte is 1024 gigabytes because tebi is larger than gibby. Now, a terabyte, on the other hand, this is probably a term you're more familiar with, that has 1000 gigabytes. So make sure you're paying attention close to those prefixes there. Then it says convert the signed denary value, -100, into an 8 bits 2's complement binary integer. So there's two ways to do this. You can start with -128 and, work backwards, trying to add some positive numbers to a negative number, or you can take a much more efficient route. The first thing you want to do is you want to write out the 8 bits and you want to get those values. You can do that on your paper, show your examiner, you know what you're doing, and then all you're going to do is you're going to find the regular value of 100. So there's the binary value for 100. I don't need 128. I do need 64. 64 plus 32 is 96, plus another 4 is 100, but that's not -100. What you want to use is the 2's complement trick. We have the positive value. We're going to start on the right-hand side, and all we're going to do is move from right to left. We're going to ignore all zeros until we get to the first one. So we're going to keep this 0 because we're going to ignore it. Keep this 0 because we're ignoring it. We've hit the first one. What we're going to do is we're going to keep that 1, and then we're going to invert every single bit after this. These 2 zeros will become 1s. These 2 1s will become a 0, and this 0 out here will become a 1, showing that we have a negative value. So this is the 2's complement representation. I've written that down as my answer, and here you can see in the first value I have -128. I don't have any 64s. I don't have any 32s. I do have a positive 16. I do have a positive 8, a positive 4. When I add that together, that comes out to -100. Convert the denary number 251 to hexadecimal. Show you're working. You'll notice this one is worth 2 points. You can't go straight from a denary number into hexadecimal. Now you can if you divide it by 16 because hexadecimal is base 16. What I would recommend that you do is you take 251, convert it into binary, which is very, very simple. You've been doing it since pre-ACE. Then split into the groups of 4. So I write out my numbers, showing my examiner I know what I'm doing. Also allows me, as I'm taking the exam, not to make a mental math mistake. So 128 plus 64 plus 32 plus 16 plus 8 plus 2 plus 1 will give me 251. The highest number I can get is 255 with 8 bits. So really, all I need to do is get rid of that 4. 255 minus 4 is 251. All I need to do now is take this binary number and I need to split it up into 2 groupings, 4 bits each. So here I've done that. I've done the left side in yellow, the right side in blue, so you can clearly see what's going on. So you can start with either side you want, but the order you write it in does matter. This orange value is going to be first in the hexadecimal character, this blue value is going to come second. So you can't swap them, and the order does matter. So the highest value I can get with 4 bits is 15. Here you can see I have 4 ones. That is the value of 15. 1 plus 2 is 3. 3 plus 4 is 7. 7 plus 8 is 15. But that's not the hexadecimal value. The hexadecimal value for 15 is F. Let's work out this other side. We see we get the value of 11. 15 and 11, those aren't hexadecimal values. But remember, if you have a number that is greater than 9, or the value is greater than 9, you have to switch to the letters. A is 10, B is 11. So I know right away this blue one is the letter B. C is 12, D is 13, E is 14, F is 15. So my answer in hexadecimal is FB. That is how you will handle that very first page. Looking at this next question is simple binary arithmetic, which is why it's just 1 point. They could have subtraction on the exam, and if they do, all you're going to do is you're going to convert that second number to 2's complement so you can follow the binary addition rules. For example, let's say they have 24 minus 7. What you're going to do is 24 plus negative 7. You're going to take that second binary number, you're going to turn it into 2's complement so you can follow those simple addition arithmetic rules. So let's go ahead and work this one out. What is 0 plus 0? Well, we know that results in 0. What about 0 plus 1? We know that's 1. 0 plus 1, we know that's 1. And then a third time, 0 plus 1, we know that's 1. When we get to 2 ones, what is 1 plus 1? That is 2. What's the binary representation of 2? That's 1, 0. So I'm going to place my 0, and I'm going to carry that 1 because it equals 1, 0, because 1 plus 1 is 2. Now I have 1 plus 0, which is 1, plus 1. So my 1 plus 0 here, plus 1, that is 2 again. Put my 0, I carry my 1. Then I have it for a third time. 1 plus 1 plus 0. Well, that's going to be a 0, and I'm going to carry my 1. 1 plus 0 plus 0 is 1. So that is my final answer. Now, you may be saying, well, hold on. That's a negative number. It does say unsigned binary integers. And when it's unsigned, you're going to treat it just like a positive number. So make sure you're on the lookout for that. Now, the one thing we did not see in this binary arithmetic was one rule that we didn't see. And that's when you have 1 plus 1 plus 1. When that happens, that comes out to 3. What's the binary value of 3? It's 1, 1. So you're going to put your 1, then you're going to carry that additional 1. So make sure you're on the lookout for that. But if you know all those rules, you'll be able to easily pick up that point. And if you've been able to do all of this so far, you're already at 5 points for your Paper 1 exam. A computer has hardware and software. The hardware includes different types of memory, and we've talked about this before. There are 2 types of memory. There is primary memory and secondary memory. Here it says random access memory and read-only memory are both examples of what type of memory. A lot of people want to say secondary, but it's actually primary. If RAM and ROM are primary memory, what's secondary memory? That is going to be your hard drive, either the hard disk drive or solid state drive that you have in your computer. Now, one item that is stored in RAM is the software or the process that's currently running. Now, remember, a program is source code that is not running. Process is source code that is running. So when you see the term process, we're talking about a program that's actually in the run state. If we're talking about a program, it's actually just source code that is not in the run state. Now for AS, you don't need to know that. But if you're an A-level student who's also retaking the Paper 1 exam, you'll know what I'm talking about there. Something else that's also stored in the RAM could be any software or data that we're currently using. One item that's stored in ROM is the operating system startup instructions. We call that the boot instructions. You can also put the BIOS, which is the basic input output system that is also stored in ROM. You don't want to put multiple answers down. And the reason you don't want to put multiple answers down here, for example, I'm not going to put the operating system startup instructions and at the same time on that same line BIOS. The reason I don't want to do that is because if one of my answers is wrong, they're not going to give me any credit. So don't try to be fancy by writing multiple answers. Just put what they want and then move on to the next blank. So it says RAM can either be static RAM or dynamic RAM, and this shows up in the curriculum as well. Now, SRAM uses transistors, and they're arranged as flip-flops. Now, again, if you're an A-level student, you know what these are because they show up in the SR or RS latches and in the JK flip-flops. So you know what those are because you have to draw those diagrams. Dynamic RAM uses transistors and capacitors. So all this comes down to is whether or not you know about the RAM and the difference between primary and secondary memory. Nothing that you can't handle. Plenty of time to brush up on those skills, but that right there will get you a total of 10 points on your Paper 1 exam. Let's take a look at the next question. Explain the difference between programmable read-only memory, PROM, erasable programmable read-only memory, EPROM, and electrically erasable programmable read-only memory. So a lot of stuff here. Now I did a short on this. It's 60 seconds. So if you need to recap these very quickly before the exam, make sure you check out that short because it is less than 60 seconds or right at 60 seconds. Now, programmable read-only memory can only be written to once because it's not erasable. So once you write to it, that's it. It's done. It's permanent. There is no changing it. Now, if you want to change it, that brings in EPROM. Now, EPROM can be written to several times. Now, before you rewrite it, though, you have to erase all of its contents. How do you do that? By using UV light, and then once all of that's been deleted, now you can write to it again. The double EPROM, that stands for the electrically erasable programmable read-only memory, and that electrically at the beginning is the big clue. It can be written to several times as well, but the difference is you don't have to erase everything before you can write to it again. You can erase sections of the content on that by using an electrical charge so it can be written to again. So the EPROM, you're going to use a strong UV light. Double EPROM, you're going to use an electrical charge because that is electrically erasable programmable read-only memory. Let's take a look at the next part. So question 2B, this is 5 points, and this is going to bring your total to 18 points. Describe the principal operations of a magnetic hard disk. This is what's used as a hard disk drive. This is not referring to a solid state drive. If they ask you about a solid state drive, you will not be able to use the answers that I have here. So the magnetic hard disk contains platters, and those platters are on a spindle. You can think of lots of records, and they're on a spindle because they're going to spin. These platters rotate at high speed, and each platter has a read head and a write head because we're either going to be reading the data to pull it onto the RAM, or we're going to be taking information that's on the RAM and putting it onto the computer, such as when we're saving files. Now, when being read from, the read head uses a current to read from the section of the hard drive that it's reading from. Now, the current that it uses is applied using a variation in a magnetic field, and that's why it's called a magnetic hard disk. It works through the properties of magnetism. When being written to, the write head uses a current to produce a change in the magnetic field on the disk so we can actually save data to the disk itself. Now, the platters are able to be magnetized and sectioned into blocks, and we call those blocks, or the blocks are actually made up of sectors, and when we have multiple sectors, we call those blocks. All data stored on the disk is stored as a magnetic pattern in each block. So it's all these magnetic properties that make it a magnetic hard disk. Let's take a look at the next one. So the last question will bring us to 18 points on the exam. The next one, 7 points here, easy points for a total of 25. Let's take a look at the and NAND, XOR, and NOR table here. Complete the table by writing one set of values. Do not write all sets of values. Could you get a table that has that? Absolutely. Here, they just want one set of values. They want one value for input 1, one value for input 2. For each gate, that will give the output 1. So what is the rule for AND gates? How do I get an output of 1? What is the condition for input 1 and input 2? Input 1 has to be 1. And at the same time, input 2 must also be 1. Those are the rules for an AND gate. Nothing you can't handle. Now, for a NAND gate, there are a couple possibilities that will get you to 1. Now, a NAND gate is a not AND gate. But let me be clear. Let's take a look at this diagram down here. This is a NAND gate. It goes through the AND gate, then it hits this inverter. For example, if I put 1 for A, B I put 1, and it goes to a NAND gate, it goes to the AND gate first, giving me a 1, hits the inverter, and then gives me a 0. So my NAND gate is going to be 0 and 0. That could give me a 1. I could also do 0, 1. I could also do 1, 0. Why is that? Well, let's take a look at 0, 0. If I put 0 through A and 0 through B, when that goes through an AND gate, 0 and 0 results in a 0. But then it hits this inverter, gives me a 1. Same thing if I choose 0, 1 or 1, 0. What's the rule for a XOR gate? Well, 1 must be true and only 1 must be true. So I can do 1, 0 or I could do 0, 1. Both of these cannot be true. If both of them are true, that's not a XOR gate, that is an OR gate. And XOR stands for an exceptional OR gate. One or the other, but not both. For a NOR gate, it's going to go through the OR gate, then it's going to hit an inverter. How do I get a 1? Well, for an OR gate, both of them could be 1, and that's going to give me a 0 when I hit the inverter. If I choose input 1 as 1 and input 2 as 0, I throw that through an OR gate. That's going to give me a 1. I hit the inverter. That changes it to a 0. If I do 0, 1, I go through the OR gate. That gets me a 1. I hit the inverter, and that gives me a 0. There's only one option I can have for the NOR gate, and that is when both input 1 and input 2 are zeros. Let's take a look at this diagram. Write the logic expression for the given logic circuit. What you don't want to do is you don't want to write the Boolean expression using those symbols. So make sure you just read it carefully. Make sure if it's asking for the logic or for the Boolean expression. In this case, we're going to use logic, so we're going to use words. So I'm going to start with this NAND gate here. So I'm going to do A, NAND B. All I'm doing is I'm identifying this gate. It's a NAND gate. I'm going to write in all caps because that's proper practice. And what's going through that NAND gate? I'm taking A and I'm NANDing it with B. Then I have this gate down here. That is the symbol for a XOR gate. What's going through the XOR gate? B, XOR, C. So I'm going to write that there. How do I combine both of these gates together? Well, I combine it right here. What type of gate is that? That is an OR gate. And I want to write A NAND B in parentheses, B XOR C in parentheses to make sure I'm keeping everything separate. And just like that, we have 1/3 of the total points we can earn on our paper 1 exam. Let's take a look at the next question. A teacher is writing examination papers on a laptop computer. The computer is connected to the internet. Teacher is concerned about the security and privacy of the papers. State the difference between the security of data and the privacy of data. Now, what you don't want to do is say the security of data is about keeping the papers secure and the privacy of data private. You don't want to say that at all. They're going to write NE on your paper, which stands for not enough. So they want to know, do you know what the security of data is? When we're talking about the security of data, we're talking about preventing loss. We're not trying to lose any data or headway that we have made. There's backups of the data somewhere, either on the cloud or on a external hard drive of some type somewhere it is backed up again. Now, when we talk about the privacy of data, we're talking about preventing unauthorized access, somebody who should not be accessing the data. Now, in this case, the teacher is the only one with permissions to access the data. Anybody else would be an unauthorized user. So, and that brings us to the next part. Identify and describe two threats to the data. Identify one security measure to protect against each threat. Each security measure must be different. That's because they don't want you to use the same one twice to pick up points. They want to see you earn those points, and we're going to show them that we can earn those points right there as we're moving forward to an A. This will give us 32 points, so this will put us very comfortably well into the passing range, but we're not interested in passing. We're interested in showing them that we can get the highest score possible. So let's go ahead and let's go over this. Threat 1. Let's talk about the unauthorized access, which is the the privacy of data. What does it mean when we say unauthorized access? Well, a hacker can make changes and or delete the exam papers. Maybe the hacker's not doing too well in the class. Maybe he or she isn't feeling confident about that final exam. Maybe they want to gain unauthorized access and delete those exam papers. How do we prevent a hacker from doing that? Well, there's a couple options we have, but we're only going to write one. Now, I'm going to list both. That way it can help you prepare for your paper 1 exam, but we can use strong passwords. You don't want to say just passwords. I have a feeling the examiner would write NE because not any password would work. You want to say strong passwords. So be specific when in doubt. You could also say by using a firewall, because a firewall will also prevent unauthorized access or help prevent that to do so. Threat 2, spyware. Well, how could spyware be used? Well, maybe a keylogger is installed without the teacher's knowledge. Keystrokes are recorded and sent to an unauthorized user. Now we can see what the exam questions are because we've recorded the teacher's keystrokes. How do we prevent that from happening? Well, let's just install and run anti-spyware. Something else you could say is run anti-malware because spyware is a type of malware. Let's go ahead and take a look at the next question. All right, question 4A. So there's 4 points and a total of 36 points. Teacher uses a relational database marks to store data about students and their test marks. Database has the following structure, and we can see the layout there. Now, there's a couple of ways this question can go. Sometimes they'll give you descriptions and ask you to show the database or table format for each table. And this one, they're giving it to us, and they want us to describe the advantages of using a relational database compared to a file-based approach. This, without a doubt, along with normalization and relational databases, will come up on the exam. It has been on the exam since 9608. There is almost a 100% guarantee this will show up on the test. It's worth quite a bit of points. So we're going to go through this section. We're going to see how many points we can earn, which is going to be all of them. But we can see how many points that it's usually worth. You have plenty of time to brush up on your skills. Sometimes SQL is added along with the relational database. So you want to make sure you brush up on those SQL skills as well. So let's go ahead and go over this. So describe the advantages of using a relational database. Well, it eliminates data redundancy because each item I'm only entering one time. Now, let me be clear when I say I'm entering it one time. Student ID, you'll notice it shows up twice. Well, that's because I'm entering it one time in each table. Now, in student test down here at this third table, it could be more than one time because I don't have a just one primary key. I have a composite key, and we'll talk about that in just a little bit. So changes made in one table are updated in another. That's why I want to use a relational database because the data is linked. I don't have to go into 15 different tables to change it. When I make the change in one table, it'll update all those others. The relationships among the tables create data integrity and consistency. Let's say a student changes their student ID. Because I have it linked right here in the student test table, it will show up or it will make that change because they're going to be tied together. So this student ID shows up here in this table, and test ID shows up here in the third table as well. Now, student ID is a primary key. Down here in the student test table, it's known as a foreign key. Test ID is a primary key in the test table, shows up as a foreign key in the student test table. Because both of these are underlined, they are a composite key. As long as the student ID and test ID together are unique, we're allowed to put it into the table. Now, complex queries can be ran and different views of data can be extracted. We're not actually seeing this right here. We can see a layout, an example of the data inside the tables, but when we extract it, that's when we'll be able to see it. All right, give the highest level of normal form the database marks is in and justify your choice. Well, I know right away it's in 3NF. My justification, well, it's worth 3 points here. So 1 for 3NF. As long as I justify it, then I'll get all my points. Well, what's the rule for 1NF? Well, in order for it to be in 1NF, there has to be no repeating attributes. When I look at that table, there are no repeating attributes. Each column shows up one time in the table. Well, I know it's at least in 1NF. Let's check and see if it's in 2NF. What's the rule for 2NF? Each field entered is dependent upon the entire primary key. There are no partial key dependencies. So I know it's in 2NF. Then all I do is I write the rule for 3NF. There are no transitive dependencies. That's how I know it's in 3NF. So let's take a look at the SQL portion. Write a structured query language script to create the table student test. You don't have to create the database here. That's already been created. We're just creating the table. This is 5 points. This is a very, very popular question. Now, when you're creating the table, you don't have to worry about inserting the data, but you do want to pay close attention to the data because that will tell you what data type it is. So the first thing we're going to do is we're going to create table student test. It tells us the name of the table. Open my parentheses. Now it's time to put in each of these columns. Not only do I need to put in the column, I need to identify the data type. So up first is student ID. That's going to be of the integer data type because there are whole numbers. I put a comma because that's not the only column I'm putting in. What's the next column I'm putting in? Test ID, not a string. Not an integer because we do have some letters. That's going to be varchar. Now, when you use varchar, inside the parentheses, you must put the length of the data that's being used. And right here, I see 2 digits or 2 characters, 3 characters, 2 and 3. Looks like 3 is going to be top of the mark. So we can use varchar. Don't forget to put in the number inside the parentheses. We put a comma. What's the last column? That's going to be mark. And that is also an integer because we don't have any decimals. But don't forget, student test has a primary or a composite key. It's a primary key that contains 2 or more columns, and that is student ID and test ID. So I need to make those my primary keys. So what I'm going to do is I'm going to look back, and you can see here are the primary keys. Primary key, student ID, comma, test ID. That will make it a primary key. But don't forget, student ID here is the foreign key for student ID inside the student table. Same thing with test ID. So I put that in my SQL command as well. Foreign key, student ID. References, student ID. So we're saying we're making student ID a foreign key. What does it reference? What does it link to? It's linked to the student table. And what attribute of the student table? Student ID. I have to do the same thing for test ID. Foreign key, test ID inside this table. References the test table. What attribute? Test ID. Now, you're not done just yet. You could be saying, what more is there to do? And this is where students miss a point. They forget to put the close parentheses in the semicolon. Let's take a look at the next question on this exam. All right, write an SQL script to find the average mark of students in test A 7. So if we nail this, we'll be at 47 points. This is pretty much where the A level range, give or take a few points, is going to begin. Remember, it's dependent upon how well students do. Now, what we're going for is the highest score possible, 75 out of 75, getting that A prime and showing Cambridge who's boss of this test. Let them know, they tried to make it difficult and we just waltzed all the way through because we're going to be as prepared as possible. And I thank you for letting me help you or assist you in that journey. So when you're doing the average mark, there's a couple other things you could do. You could do sum, you could do count, it could be in ascending order, descending order. So you want to make sure you know how to use all those. Now, if you're familiar with programming in VB.NET, I do have a video where I've written a program where you can actually use SQL commands to actually manipulate data inside of a table. So if you really want to practice unlimited SQL practice, make sure to check out that video. I show you very easily how you can create an SQL program, put in SQL commands that actually affect a table. So that will give you unlimited practice. Anyway, let's do this one here. We don't need to keep hearing me talk. So the first thing we're going to do is select. Select is going to give us the output. We're saying, hey, I want to select the following data. I want to output it so I can see it. That's what we mean by different views. I use AVG, which is the command for average. What do I want the average of? I want an average of all the marks. Well, I need to know what table mark can be found in. Well, that's from the student test table. That's where I find the mark, and anywhere where the test is A7. So I use my where command, which is like if student ID equals A7. We don't have if statements, so we use where, which are our conditional statements in SQL. Now the A7 needs to be in single quotes. If you look, some people put it in double quotes. Is there a difference? Yes, there is. Single quotes are used for string-based text. If it's an integer, don't put quotes around it. Double quotes are used for identifiers or column headings that show up in SQL. Single quotes, string text, double quotes, identifiers. Two different things entirely, so you want to make sure that you do it correctly. All right, let's move on. So this will give us 51 points if we get this, and we will. The mark a student is awarded in a test will be entered into the database. This mark needs to be a whole number between 0 and the maximum number of marks for that test inclusive. Explain how data validation and data verification can be used when a mark is entered. So what we want to do is we want to show some validation techniques, explain why they're used, and do the same thing for verification. Now, it does not just say explain the difference between data validation and data verification. They do tie it directly into this question by saying can be used when a mark is entered. So validation, I can use a range check, I can use a type check, and I can use a presence check. Those are validation techniques. Now, range. I'm asking, is it between 0 and the maximum marks? That's why I'm using a range check. I want to make sure it's in between 0 and the maximum number of marks. Now, what I should have done is I should have said, is it between 0 and the maximum marks inclusive? Just being a little more specific there, because they do mention that it is inclusive. Type. Is it the correct data type? That's what type refers to. Is it an integer value they've entered and not a real data value they entered? Now, if you're not familiar with real, that is any number with a fractional part. A fancy way of saying a number with a decimal. We want to make sure it's a whole number that they have entered because it does mention whole number in the question. Then the presence check. Has data actually been entered? Is the text box empty? Has a user actually put a number inside the text box? Those are our validation techniques. We don't know if the data is accurate. We just want to make sure that it's in the correct range, that it's the correct type, and that it's actually been entered. Data verification, that is where we are checking the accuracy, and we can do double entry and visual. Double entry, we enter the data twice to make sure it matches. You probably have seen this multiple times when you sign up for an account. They don't have you enter your email once. Sometimes we'll have it enter it twice, or even your password twice. That is to make sure the data matches. That is double entry. Another you could use is a visual check, manually comparing the data entered with the data on the test. So that is the difference between data validation and data verification. Let's take a look at this next one. This will bring your total to 55 points. Nothing that you can't handle. Plenty of time to brush up on any skills that you feel uncertain about. A programmer uses an integrated development environment to develop a program. That's going to be BlueJ, Visual Studio. Maybe you're using Idle if you're doing Python. Maybe you're using PyCharm. Those are IDEs. We're allowed to write code and then run it all within a single application. Draw one line from each IDE feature to its correct description. So these are examples of IDEs or features that most IDEs have. Something that's not on here that you may want to check is Pretty Print. And that is the actual term, Pretty Print. And what it does is it allows you to see your code. It's in various colors based on certain keywords that you use. You may want to study that too, because that is also a feature. It just doesn't show up on this test. So context-sensitive prompt. Well, it displays predictions of the code being entered. If you start typing in a variable name, it may say, hey, this is the variable you're trying to type in. It's going to go ahead and bring it down it's going to show up for you so you can easily select it. Then we have a dynamic syntax check. Underlines or highlights statements that do not meet the rules of the language as soon as you start typing. If you type if, then, but you don't type end if, that's a dynamic syntax check. It's going to underline it in red. It's going to say, hey, you have a if statement, but no end if. A breakpoint, probably heavily underutilized. This is when it stops the code executing at a set line. That way you can check the report window and see what your variables are. You can also use the report window with single stepping. What does single mean? It means one, executes one line of the program at a time. When that one line is done, it then pauses your program. It doesn't necessarily stop. Stop makes it sound like the program's actually closing. What it really means is it pauses. It allows you to see all the data as it's being updated, the variables, whatever it may be, and all that shows up in the report window, which outputs the contents of variables and the data structures that you're currently using as you run through your code. So those are features of IDEs. That puts us at 55 points. Let's take a look at the next part of the question. The programmer wants to allow users to edit, improve, and redistribute the program. Identify two different types of software license that the programmer could use. Well, there's two ways that we're allowed to edit the source code and redistribute that improved source code. One way is through free software, and that is done through the Free Software Foundation. Another one is open source, and that is done through the Open Source Initiative. Some other licenses you need to be familiar with are shareware and commercial. You want to be familiar with those as well, because those are the other licenses, and I'll be making a short covering all the different licenses that you'll need to know for your Paper 1 exam. Now, question 5C is explain the benefits to the programmer of using program libraries. This will bring us to 60 points. Now, there are two types of libraries they could ask you about. That is dynamic link libraries and static libraries. Yes, we're going to answer this question, but I want to give you all the information you're going to need to help make you successful. Let's start with static libraries. Static libraries are part of the program that uses them. Because they're part of the program that uses them, it's going to respond much faster because it's part of the program. The downside to a static library is that it makes the file size larger because it is embedded inside that program. A dynamic link library is linked to the program. It is only used when it is called. Because it's not part of the program, the advantage is the file size is smaller, and it can also be used across multiple programs because it's not part of any program. The downside to a dynamic link library, though, is because it's not part of the program, it's actually going to run a little slower. And they could ask you the difference between those. But let's go ahead and let's answer this question. Explain the benefits to the programmer of using program libraries, static or dynamic. Well, code's already been written and tested. We're pretty sure that code inside the library is going to work. And this saves time since code doesn't need to be written from scratch. We don't have to come up with it. It already works. Think about the math library you've used in your coding experience as you've gone through this course. You've probably used math.round, math.truncate, math.sqrt, which is square root. You have a math library and you're calling those methods that allow to do the work for you. You're not having to write that code from scratch. Making changes to the library will automatically make changes in the program when that library is being used. We're not updating code inside the program. What we are doing is we're updating the library to make some changes, whatever it may be, and those changes will automatically carry over to the program as long as we don't change the calls that are being used. It can handle complex mathematical calculations that the programmer may not be able to do. If you had to do square root, you have a library, what code would you write to do that? Well, if you don't know, then you would use the math library. So nothing to worry about there. Question 6A1, 5 points. This will bring the total to 65 points. Computer systems is designed using the basic von Neumann model, that is the fetch execute cycle. Describe the role of registers in the fetch execute cycle. Now for this one, I'm going to put it in order. It doesn't say that it has to be in order, but I'm going to put it in order, starting with the program counter. It holds the address of the next instruction to be fetched. It doesn't hold the data. The data is the address that it holds. Now, the memory address register holds the address of where the data is fetched from. So the program counter is going to take its contents and put that into the memory address register. Well, the contents held at the address, not the address, but the contents at the address is going to be placed into the memory data register, and that is going to be returned back to the current instruction register, which is the CIR. Now, as soon as that information is placed into the current instruction register, that is when the program counter is incremented. It is after it is placed into the current instruction register, but before it is decoded. The instruction in the current instruction register is decoded, and then those instructions, whatever they may be, they are executed, and then it repeats back here at the top with the program counter taking that next address and putting that into the memory address register, and the cycle starts again. That is the entire fetch execute cycle. Now, interrupts are detected in the fetch execute cycle, and describe how the interrupts are handled. Well, how are they detected? Well, at the end of the fetch execute cycle. You can't do it in the middle or during it. It has to be at the end of the fetch execute cycle. Now, we don't mean at the end of the program. We mean as soon as those instructions are decoded, then we check for interrupts. So the priority is checked. So we have an interrupt. It's the end of the fetch execute cycle. We check the priority. If it has a higher priority, the current process, the program that's currently running, is saved onto the stack. Now, the type of interrupt is identified in the interrupt service routine, also known as the ISR, which is the abbreviation for the interrupt service routine, is loaded to handle the interrupt. The computer doesn't magically know how to handle that interrupt, but the interrupt service routine is like a handbook that tells the computer, okay, here's how we're going to handle this interrupt. Now, after the interrupt is handled, it then checks for any more interrupts. If there are more interrupts, the one with the highest priority is handled after the prior one is resolved. So we check for the highest priority. Once that's handled, if there's another interrupt, we check for the next highest priority. We don't do it in the middle. If there are no more interrupts, the process is reloaded from the stack and the fetch execute cycle resumes, again, starting with fetch, starting with the program counter. You cannot check for interrupts during the middle of the fetch execute cycle. And that brings our total to 70 points. Let's take a look at the last couple questions to get our full 75 on this paper 1 exam. Identify one factor that can affect the performance of the computer system and state how it impacts the performance. Nothing you can't handle. They want one. I'm going to give you 4 that you can choose from, giving you all the information you need, not just going through the questions and writing down some answers, but explaining it to you and giving you all the information you need. The most common factor that's going to be chosen most likely is going to be clock speed. And there's nothing wrong with choosing clock speed. Most students are more familiar with that than anything else. What does clock speed do? How does it impact the computer? Well, that means more fetch execution cycles can be done per second. Each pulse of the clock, you can do a fetch execute cycle. Now, something they didn't ask about that they could ask you about is how clock speed give a benefit and drawback. A benefit would be more calculations done per second. The drawback is by increasing your clock speed, it produces a lot of heat. How do you get around that? You put heat sinks into your computer or some type of thermal paste that will protect those components from overheating. Once it reaches a certain temperature, your computer will shut off, and that is to protect the internal components. That's enough to get us 2 points. But let's talk about some other options that you could use. You could talk about bus width. More data can be transferred each time. Bus width refers to the amount of wires, each wire carrying 1 bit. The benefit is more wires allow the data to be transferred faster because you're transferring more data. Again, the drawback, more wires mean more cost from the user. More wires also mean you need more space inside the computer, which could also raise the price. Factor 3, more cores allows more instructions to be done simultaneously. So instead of using 1 core, we're using more than 1 core, allowing it to run a little faster. Then we have memory cache. More cache allows frequently used instructions to be saved and used again for fast access. Again, you don't want to choose all those factors. It says specifically identify one, but I want to give you everything that you need. Let's go ahead and take a look at the next part. Oh, good. Here we have some bitwise operations. Table shows part of the instruction set for a processor. Processor has one general purpose register, the accumulator. That's fine, not a big deal. Complete the register to show the result after the instruction and hashtag or #2 is executed. So I look at and, its operand is going to be a number, and that's why they have the number 2 here. Bitwise and operation of the contents of the accumulator with the operand. What in the world does that mean? All you're going to do is treat it just like an AND gate. You're going to follow those same rules. Now, where do we put that to? Well, we're going to put it into binary. Boom. There it is in binary. Remember, you have 1, 2, 4, 8, 16, 32, 64, 128. So all I did was use 8 bits to represent the number 2. The hard part is over. I mean, that wasn't too bad. The hard part's over though. All I got to do now is follow the AND rules. What happens when I put 1 and 0 through an AND gate? I get 0. What happens when I put 0 and 1 through an AND gate? I get 0. What happens if I put 1 and 0 through an AND gate? I get 0. What happens if I put 1 and 0 through an AND gate? 0. What about 0 and 0? I get 0. What about 1 and 0? I get 0. What about 1 and 0? I get 0. What about 0 and 0? I get 0. And that is the new updated register when we AND it with the binary representation of the number 2. Take a look at the next one. Complete the register to show the result after the instruction or number 8 is executed. So we look at or, bitwise or operation of the contents of accumulator with the operand 8. What in the world does that mean? You're going to follow the same rules that you use when you put it through an OR gate. We get the representation of 8. Again, this first is 1, second one is 2, third one is 4, fourth one is 8. That's the binary representation of 8. All I do is follow the OR rules. What happens when I use 1 or 0? That results in a 1. What about 0 or 0? That results in a 0. 1 or 0 results in a 1. What about 1 or 1? That results in a 1. If it was a XOR operation, then it would be 0. Or at least one value has to be true. XOR, only one value can be true. What about 0 or 0? That's a 0. What about 1 or 0? We have it 2 times in a row. So that's going to be 2 ones. What about 0 or 0? That's going to be a 0. That is the new updated register after we ran the instruction OR number 8. That brings our total to 74 points. We're now going to show Cambridge we just got a perfect score by doing this one. Complete the register to show the result. After the operation, LSL number 4 is executed. So LSL, bits in the accumulator, are shifted logically in places to the left. So we're not performing any math. We're just shifting it 4 places to the left. Zeros are introduced on the right-hand side. So this first 0, there's no room for it. It just gets cut off. There's nowhere for it to go. This one, if we shift it 4 places to the left, it's outside the register. There's no place for it to go. It's gone. What about this third 0? There's nowhere for it to go. What about this 0? Do I start there? Well, remember, you're shifting 4 places to the left. So it would be here. 1, 2, 3, then 4. There's nowhere for it to go. There's no more room. So it's out of here. It's just got to go. So we start with this one right here. We start with this one, and we're going to move it into this first box. We put our 1 there. Then we take a look at the second one. We're going to shift it 4 places to the left. Put a 1 there. We're going to take a look at the 0. We're going to shift it 4 places to the left. 1, 2, 3, 4. We know it goes inside this box. We put the 0 there. This 1 shifted 4 places to the left. So it'd be here. 1, 2, 3, 4. We know it's going to go in this box. What do we do with all these boxes left over? Well, we put zeros there because zeros are introduced on the right-hand side. I hope you guys found this paper 1 full walkthrough helpful. If you did, please take a moment and give it a thumbs up and subscribe to help the channel grow. And we'll see you guys in the next programming video.